Coefficient of restitution. Coefficient of restitution. Mathematically, it is given by E is equal to V2 minus V1 by U1 minus U2. V2 minus V1 by U1 minus U2. V2 minus V1 is the relative velocity of separation of the two bodies after collision. The relative velocity of separation. U1 minus U2 is the relative velocity of approach. The relative velocity of approach. The ratio of relative velocity of separation to the relative velocity of approach, this ratio is called coefficient of restitution. Coefficient of restitution. The value of E varies from 0 to 1. 0 to 1. E is equal to 1 for elastic collision. E is equal to 1 for elastic collision. E is equal to 0 for perfectly inelastic collision. For perfectly inelastic collision. So, the value of E lies between 0 and 1. 0 is less than, E is less than 1. If it is elastic collision, the value of E is 1. As the loss of energy increases, the value of E approaches 0. When the bodies stick together, that is perfect inelastic collision, then the value of E is 0. Then the loss of energy is the highest. This indicates, E value indicates the loss of energy. Coefficient of restitution. In the case of a body rebounding from the earth. Rebounding from the earth. In the figure, the circle represents a body which falls from a height h1 and then rebounds to a height h2. h1 is the initial height. So the body is dropped from a height h1 and it hits the ground and rebounds to a height h2. It raises to a height h2. Then let us suppose the body hits the ground with a velocity u1. The body hits the ground with a velocity u1 and then rebounds with the velocity v1. Just after collision with the earth, it moves up with the velocity v1. So u1 is just before collision and v1 is just after collision. Just before collision, the velocity of the falling ball is u1. Just after collision, it is v2. Now, here the two bodies are the body falling from certain height and earth. First body is the body falling from height and the second body is the earth. The earth is at rest before collision and after collision. So, u2 is 0 and v2 is 0. So, since it is second body, its initial velocity is 0, final velocity is 0. u2 is 0 and v2 is 0. We can show that u1 is equal to square root of 2gh1 and v1 is equal to minus square root of 2gh2. Because u1 is in the downward direction, let us consider downward direction as positive. Then u1 is equal to square root of 2gh1 and v1 is equal to minus square root of 2gh2. Let us substitute these two values in the relation for E, coefficient of restitution, which is v2 minus v1 by u1 minus u2. E is equal to v2 minus v1 by u1 minus u2. v2 is 0 and v1 is minus of square root of 2gh2. So, minus of square root of 2gh2 divided by u1 is square root of 2gh1 minus u2 is 0. So, by simplification, we will get E is equal to square root of h2 by h1. And simplification, we will get E is equal to square root of h2 by h1. Calculation of the rise in height after number of rebounds, number of collisions. We have the relation E is equal to square root of h2 by h1. E is equal to square root of h2 by h1. Let us take the initial height as h and the first rebounding height as h1 and the second rebounding height as h2. Like this, when we take the values of h1, h2, etc., then we will get h1 is equal to E square h. From E is equal to square root of h1 by h2, instead of h2 we take it as h1 and h1 is considered as h, then E is equal to square root of h1 by h. So, h1 is equal to E square h. Similarly, we can write h2 is equal to E square h1, h3 is equal to E square h2, etc. Let us try to convert h1 in terms of h. Then h2 is equal to e square h1, but h1 is e square h, so we will get h2 is equal to e square whole square into h. h3 is equal to e square h2, so h3 is equal to e square whole cube into h. In general, hn is equal to e square whole to the power of n h. So hn is equal to e to the power of 2n h, e to the power of 2n h. Using this relation, we can find the final height to which the body raises after number of rebounds.